This is section 3.4, part B, exponential and logarithmic equations. So at the beginning of this section, in section 3.4, part A, we were solving problems where we were getting the bases the same and then setting the exponents equal. If you cannot get the exponents the same, you're going to have to solve these a little bit differently. So this is an example of that type of problem. So there's no way we can get 4 and 3 to be the same number. So we're going to have to solve this using logs. Now we want to get the variables out of the exponents. So just like we did in section 3.4 part A, we're going to take the log of both sides so that we can then move the exponent down in front. Now we can move the exponent in front of it and turn it into multiplication. Now we want to get the x's by itself. To do this, we're first going to have to distribute on both sides. So on the left, we're going to distribute that log of 4, and on the right, we're going to distribute log of 3. Now we're going to take all of the x's to one side, everything that's not an x to the other side. So first, we can add x log of 3 to both sides. And then we can add a log of 4 to both sides. Now on the left side, each of them have an x, so we're going to factor an x out of each piece. Now this is x times 3 log of 4 plus log of 3. Right now it's multiplication. To get the x by itself, we can divide on both sides. So this is going to leave us with x is equal to 2 log of 3 plus the log of 4 all over 3 log of 4 plus the log of 3. Now when you put this into your calculator, it'll give you an exponent of a parenthesis right here. Make sure you close that parenthesis. It'll give you parenthesis in front of the 4. Make sure you put one behind the 4. And make sure you are very careful with all of your parentheses when you put this into your calculator. And when you're done, you should get x is equal to 0.682. Now for this example, we're just going to solve for x. Now if you look, this looks kind of similar to a problem that would be in the form of u squared plus 6u minus 16. So that means for this problem, we're letting u equal e to the x. And we're letting u equal e to the x because we know how to factor it if this is just with the u. So we're going to factor this trinomial. What multiplies to get u squared is u and u. What multiplies to get negative 16 is a positive 8 and a negative 2. So we know that u plus 8 is equal to 0 and u minus 2 is equal to 0. Or we know u is equal to negative 8 and u is equal to a positive 2. But we have to plug back into the original. So we let u equal e to the x. So we're going to replace our u with e to the x. Now to get the x by itself, we are going to take the ln of both sides because the ln and e will cancel. Now the one on the left, you cannot take a log of a negative number, so that will not give us a solution. But on the right, the ln of 2, we will see that x is going to equal 0.693. On this example, if we can just get one ln on both sides, then we can cancel them out. If we have the same log base on both sides, those logs can disappear. So if I have ln of x plus 2 plus ln of 3x minus 2, remember addition, when you condense it, turns into multiplication. And when you have a number out front, 2 times the ln of 2 to the x, you can take that to your exponent. And this can just become ln of 2x squared. Now since we just have an ln on both sides, this is a log with the base e. Those are both the same bases. Our ln's can cancel. And we're just going to be left with x plus 2 times 3x minus 2 is equal to 2 squared is 4, x squared gives me x squared. Now on the left side, we are going to need to FOIL. X times x gives me 3x squared. Outside, negative 2 times x is negative 2x. Inside, 2 times 3x gives us 6x. And last, 2 times negative 2 gives us negative 4. If we combine like terms on the left side, we left with 3x squared plus 4x minus 4 is equal to 4x squared. Now we want to take everything to one side. Normally, we should take everything to the side that has the largest value on your largest exponent. So I'm going to go ahead and take everything to my right side. So we're going to subtract the 3x squared. 4x squared minus 3x squared is just x squared. If I take that 4x over, right now it's positive, so to move it, we're going to subtract it. And we currently have a negative 4, so take it to the side, we are going to add it. Now we can factor. What multiplies to get x squared is x and x. What multiplies to get 4 that adds to get a negative 4 will be negative 2 and negative 2. So we know x minus 2 is equal to 0 and x minus 2 is equal to 0. Since these values are the same, our x value will just be 2. Now if we would end up with 2 and negative 2, we would need to plug it back into the original to make sure we wouldn't end up with any extraneous solutions. On this last example, once again, we are going to need to condense on the left side. Now we have a log on the left side, but we do not have a log on the right side. But to get rid of that log base 12, we can make both of those exponents. Now our 12 and log base 12 will cancel. And 12 squared gives us 144. Now if we distribute, 12x times x is 12x squared. 12 times 1 gives us a negative 12. If I add, that's negative 12x because we're distributing 12x. Since I have an x squared and an x, we're going to take everything to one side. Now to make our factoring a little bit easier, 12 does divide into everything. So if we divide everything by 12, we want to see what multiplies to get a negative 12, that adds to get a negative 1. This would be negative 4 and a positive 3. But we need to make sure when we plug this back in that these will work. So if I do the log base 12 of 4 minus 1 in this part right here, 4 minus 1 is 3. I can take a log of a positive number. But if I were to plug in negative 3 minus 1 is negative 4, and you cannot take a log of a negative number. So that is an extraneous solution. So the only answer is x is equal to 4.